For thousands of years, humanity has stared into the night sky and noticed a tiny red spark glowing quietly among the stars. Ancient civilizations saw it long before telescopes existed. To the naked eye, it looked like a wandering ember drifting across the heavens, sometimes brighter, sometimes fainter, always mysterious. That small red light would later be known as Mars, and for centuries it ignited one of the most powerful dreams humanity has ever had, the dream of stepping onto another world. What makes this moment in history extraordinary is that the dream may no longer belong to distant centuries. For the first time since humans began studying the cosmos, scientists believe that within the next couple of decades, people could actually walk on Mars. Not robotic explorers, not remote probes, real human beings standing on the dusty surface of another planet. Yet the moment you hear that idea, a question naturally arises. Earth is stunningly beautiful. It holds oceans that stretch across the horizon, forests teeming with life, skies that glow blue in the daylight and explode with stars at night. If humanity already lives on such a remarkable world, why risk everything to travel hundreds of millions of kilometers to a cold, barren desert? The answer begins with a truth that is both unsettling and impossible to ignore. Earth will not remain safe forever. 66 million years ago, long before humans ever existed, a catastrophe unfolded that changed the course of life on our planet. A massive asteroid slammed into Earth with unimaginable force, triggering one of the most devastating events in the history of life. The impact unleashed global fires, earthquakes, and a thick cloud of debris that blocked sunlight across the planet. Within a geological blink of an eye, ecosystems collapsed, and the dinosaurs, creatures that had dominated Earth for more than 160 million years, vanished. It happened because of one cosmic accident. Now imagine a similar event occurring today. Modern civilization is incredibly advanced, but it is also fragile. Cities, technology, economies, and global infrastructure depend on the stability of a single planet. If a large asteroid struck Earth tomorrow, or if a massive volcanic eruption darkened the sky for years, humanity could face an existential crisis unlike anything in our history. This realization has led many scientists and futurists to an uncomfortable conclusion. If our species wants to survive for thousands or even millions of years, we cannot remain confined to one world. Humanity must eventually become a multi-planetary civilization. But choosing where to go is not simple. Our solar system contains 8 planets, yet most of them are immediately ruled out. Some worlds are far too extreme for human life. Others are giant spheres of gas with no solid ground to stand on. Consider the scorching inferno of Venus, often called Earth's twin because it is similar in size. At first glance, it might seem like a reasonable destination, but once scientists studied its environment more closely, they discovered something terrifying. Surface temperatures on Venus reach around 450 degrees Celsius, hot enough to melt lead. Its atmosphere is dense, crushing, and filled with clouds of sulfuric acid. Any spacecraft that attempts to land there survives only briefly before being destroyed by the hostile conditions. Then there are the giants of the outer solar system, such as Jupiter and Saturn. These enormous planets have no solid surface at all. They are swirling oceans of gas, where pressure and storms grow more violent the deeper you descend. However, Mars is different. Though far from welcoming, it possesses several characteristics that make it the most realistic candidate for human settlement. A day on Mars lasts about 24 hours and 37 minutes, remarkably close to an Earth day. The planet tilts on its axis in a way similar to Earth, which means it experiences seasons as it travels around the Sun. And unlike the gas giants, Mars has a solid surface where buildings, machines, and perhaps even cities could one day stand. Scientists have also discovered that Mars holds enormous amounts of frozen water. Vast ice deposits exist at its poles, and additional ice lies buried beneath the reddish soil. Water is not only essential for drinking, it can also be split into hydrogen and oxygen, providing both breathable air and rocket fuel. And perhaps most importantly, Mars is relatively close by cosmic standards. On average, it sits about 225 million kilometers from Earth, a distance enormous for humans, but manageable with modern space technology. Yet proximity does not make the journey easy. Traveling to Mars requires extraordinary precision and patience. Both Earth and Mars orbit the Sun at different speeds, which means spacecraft cannot simply launch whenever they want. Instead, missions must depart during a narrow launch window that appears roughly every 26 months when the planets align favorably. Once a spacecraft leaves Earth, the journey lasts between 7 and 9 months. During that time, astronauts would drift through deep space, completely isolated from the planet they left behind. If anything went wrong during the mission, returning immediately would be impossible. In fact, early Mars missions are sometimes described as the closest thing humanity has ever attempted to a one-way journey. And when explorers finally arrive, they will encounter a world that feels both familiar and alien at the same time. Mars earns its nickname, the Red Planet, from the iron-rich dust covering its surface. The soil is filled with iron oxide, essentially rust, which gives the entire landscape a deep reddish color. Endless plains stretch across the horizon, broken by towering volcanoes and vast canyons carved billions of years ago. Above that dusty ground, the sky itself looks strangely different. Instead of Earth's brilliant blue atmosphere, Mars displays a hazy pinkish-brown sky that casts an eerie glow across the terrain. But the real dangers are invisible. Mars possesses an atmosphere so thin that it contains only about 1% of the pressure found on Earth. Worse still, that thin atmosphere is composed mostly of carbon dioxide. For humans, breathing the Martian air would be fatal within minutes. Without a protective spacesuit, a person standing on the surface would lose consciousness in roughly 15 seconds and die soon afterward. Temperature is another brutal obstacle. The average temperature on Mars is around -60 degrees Celsius, colder than most places on Earth. In some regions, it can plunge to -125 degrees, a level of cold that would freeze exposed tissue almost instantly. Then there is radiation. Earth is shielded by a powerful magnetic field that deflects much of the dangerous radiation streaming from the Sun and deep space. Mars lacks this protection. As a result, cosmic radiation bombards its surface constantly. A human living on Mars for a single year would receive roughly the same radiation exposure that someone on Earth accumulates over 8 years. In every sense, Mars is a hostile environment. And yet, humanity is determined to reach it. At the center of this effort stands the private aerospace company SpaceX, founded by the entrepreneur Elon Musk. Musk has repeatedly stated that his long-term goal is nothing less than building a self-sustaining city on Mars, one capable of supporting a population of 1 million people. At first, the idea sounds almost absurd, but the technology being developed today suggests that it might not be as impossible as it once seemed. SpaceX is building a massive spacecraft called Starship, designed to become the most powerful rocket ever constructed. Unlike traditional rockets, which are used once and then discarded, Starship is designed to be fully reusable. After launching into space, it can return to Earth, land vertically, and be prepared for another flight. This single innovation could dramatically reduce the cost of space travel. For decades, launching rockets cost enormous amounts of money because each vehicle was destroyed after one mission. Reusable rockets change that equation entirely, making frequent journeys between Earth and Mars far more realistic. The strategy for colonizing Mars begins cautiously. Before any humans traveled there, multiple unmanned missions would deliver equipment, supplies, and construction tools to the planet's surface.
Robotic systems could begin assembling infrastructure in advance, deploying solar panels, preparing landing zones, and constructing the first shelters. Only after those systems are in place would the first astronauts embark on the historic voyage. These pioneers would be among the bravest individuals in human history. They would leave Earth knowing that returning might not be guaranteed. Their mission would be to build the foundations of a new civilization. Initially, they would live inside pressurized habitats transported from Earth, sealed structures designed to maintain breathable air, stable temperatures, and protection from radiation. But scientists believe a more sustainable approach would involve building shelters beneath the Martian soil itself. Just a few meters underground, the thick layers of soil can block much of the radiation striking the planet's surface. Underground habitats would also provide natural insulation against extreme temperature swings. Another remarkable idea involves using giant